Good day, everyone. Let me introduce myself. My name is Anita Yuliyanti, and I'm from the Research Center for Geotechnology, National Research and Innovation Agency of Indonesia. And today I'd like to talk about my research entitled Environmental Study of the Potentially Harmful Elements, or PHE, in Talaga Budas's Geothermal Field, Indonesia. The outline of my presentation today will start with introduction, next is methodology, and continue with results and discussion, and last is conclusions. So let's start with the introduction. As we knew that the soils in the area around the volcanoes are famous with their fertility. The soils derive from the weathering of volcanic rocks, which are the result from volcanic eruptions, and these volcanic rocks are widely found in Indonesia because Indonesia is surrounded by the range of active volcanoes. But then, what makes this soil so fertile? The key is the geochemical substance that provide enormous nutrients for the plants. However, the similar substances might also be responsible for some disease and health problems in human. This is based on the findings of previous study in the other countries, suggesting that volcanic rocks and soils may contain a significant concentration of hazardous substances in the form of potentially harmful elements such as arsenic, cadmium, and so on. Potentially harmful elements is basically a group of elements which can be found naturally in the soils, in the water, in sediments, that we have to be aware of because of their toxicity. They can be defined as elements that are toxic at certain concentration to one or more species, but in many cases are also essential nutrients at lower concentrations. It consists of non-essential elements such as arsenic, cadmium, mercury, lead, which belongs to heavy metals, and they are considered the most toxic and have attracted the most attention worldwide, while the others are likely harmful, but they may play some beneficial function that they need more investigation. Among the researchers, there might be slightly differences in the PHE's member. As I mentioned before, our study focused on the geochemistry of superficial volcanic rocks around the geothermal area and addressed several elements including vanadium, chromium, cobalt, copper, zinc, arsenic, selenium, cadmium, stibbium, mercury, and lead. The excessive exposure to such elements potentially brings an adverse health effect from the acute poisoning. There is also indication that these elements may be absorbed by plants and contained in the food product such as chocolate that were planted in volcanic soils. This raised a concern whether volcanic rocks in Indonesia also contains such hazardous substances. Our research area is located in the Nature Tourism Park area of Talaga Budas Garut, which we can see here is not far from agricultural and plantation area in the northwest part of this picture. The results of our research on the superficial volcanic rocks in this area from the crater lake rim up to a radius of about 1 kilometer indicate the presence of several potentially harmful elements in a significant concentrations. Our findings also strengthen the research in another country that revealed the presence of this substance in volcanic rocks. In Indonesia, the land use of this such area or volcanic area for agriculture, plantations, and for tourism potentially increase the exposure to these potentially harmful or toxic elements, and it needs to be addressed because excessive exposure to such elements pose a significant risk to human health. Our methodology adopts an integrated method of the iterative 2 sigma method to determine geochemical background value of the volcanic rocks. The samples were collected from 5 geothermal prospect areas that are Mount Argopuro, Dieng, Mount Slamet, Mount Papandayan, and Karaha Talaga Bodas area. They were analyzed using ICP-MS method, and the result is a range of concentration of elements that we call it as geochemical background. On the other hand, the environmental evaluation was done using another set of superficial rock samples from Talaga Bodas and Karaha that were analyzed using PXRF or portable XRF method. The results were processed in Microsoft Excel to get the descriptive statistic values of the elemental concentrations. These data were used to determine the elemental enrichment factor or EF with respect to the references material. Here we use zirconium as conservative elements for normalization and upper continental crust geochemical composition as reference material. This data also processed in MapInfo to create the grid map of the elemental distributions, and the result then is used in the evaluation of potentially harmful element status in the studied area. And here are the results of our research. This is the summary of the elements concentration, the geochemical background value, and the elemental enrichment from the study. These results show that volcanic rocks in the studied area considered enriched with arsenic, chromium, cobalt, and stibbium compared to average volcanic rocks composition are the geochemical background values. This graph shows the elemental concentration relative to the geochemical background value and element threshold value that were adopted from several countries. The average arsenic concentration in the samples is almost fourfold of the background concentration and classified as moderate to significantly enriched. Another element like stibbium was identified with very high enrichment. The average concentration is almost 40 times the background concentration. Another element, cobalt, is identified with significant enrichment. However, the locality is limited and only identified in the samples from Karaha Bodas site. This study could not determine the mercury background value due to the lack of data points. However, it is noticeable that the concentration on the several samples is relatively high, even more significant than the threshold limits in the references. Even though the chromium concentration has been identified to have moderate enrichment, we can see here that the average concentration is still less than the threshold references. Contrary, vanadium concentration is identified with depletion to minimal enrichment. However, we can see here that the average concentration is greater than the threshold in the references. On the other side, the rock sample from Talaga Karaha Bodas geothermal fields show lower zinc concentration. And another element to be mindful is cadmium, which on several samples show concentration more significant than the references or the threshold limit that were used in several countries. The next figure shows elemental spatial distribution in the studied area. This geochemical map suggests that the distribution of the elements is inhomogeneous. The anomaly are localized in some spot in the studied area. And here we come to the conclusion. From the study, we conclude that volcanic rocks and volcanic soil in the studied area are potentially contain PHEs in significant concentration, and there is a lack of local references for soil quality in Indonesia. References that were used were adopted from other countries, and they are not necessarily suitable with the geological condition in Indonesia. We consider that formulating soil geochemical threshold is important to assess the level of threat from the presence of hazardous substances and or the level of elemental deficiency in the soil to ecosystem and human health. And furthermore, this insight is expected to increase awareness and open opportunities for new studies that strengthen the reasons for the need for the policies related to soil quality standard as a more suitable reference for evaluating soil quality in Indonesia. I think that's all my presentation today, and thank you for your attention.